Hi everyone, welcome to SEPA Education. The topic that we are covering today is atoms, elements, and compounds. This is the very first chapter and a very integral concept for AQA GCSE chemistry because this topic is the foundation, it serves as the foundation, and these concepts are really important for you to build strong concepts moving forward. So let's get into it. Let me just set. Okay, let's start. So, the very first thing that I want to do is let's talk about atoms. What exactly is an atom now? This definition is important. The definition of an atom is important because the examiner can ask you for the definition for either 1 mark or it can show up as a 2 mark question, and it has also previously shown up in the past papers multiple times. So, what exactly is an atom? An atom is the tiniest particle that makes up any substance, any object around you. It can be the perfume bottle lying on your vanity, or it can be like a piece of wood, the door. Even your door is made up of atoms. An atom is basically all substances are made from tiny particles. All substances are made from tiny particles, and these tiny particles are called atoms. Now, there was a guy who once did an experiment. The experiment that he did was he basically took a piece of wood and he started to chop the wood into tiny pieces. So, this is what he basically started doing. He started dividing the piece of wood into tiny pieces. And there came a point where, beyond which, he could not divide the wood into a smaller piece. And this is when he called the small piece of wood that he was not able to further divide or further make a smaller piece out of, he called it an atom. And referring to the same experiment, the same idea, we say that an atom is a tiny particle that makes up all the substances, all the objects, everything, and it is also basically something that cannot be further divided. Particles that cannot be further divided into a smaller, let's call it piece, right? They cannot be further divided. Now, the word atom comes from the word atomos. And this is a Greek word, by the way. You know why it comes from the word atomos? Because the person, the smart guy who conducted this sort of, let's call it an experiment, was called Atomos. He was named Atomos, and this we basically came up with the word atom after his name, because he was the one who came up with the word atom, considering from the wood experiment that it cannot be further divided. Okay, so we've got what an atom is. Let's take the example of a pencil. This is the pencil we use to write. We can divide this into further pieces, into halves, into quarters, into thirds. And the smallest part, if I was to basically zoom in onto one of these divided chunks, this is what I am likely to get. Let me zoom in. There's a chance that this is what my microscope looks like. And you know what these circles are? You know what these circles, these round shapes represent? These are your particles. These are your tiny particles that are undivisible. They cannot be further divided. And because they are undivisible, this is why, thanks to Sir Atomos, we came up with the word for them and we now call them an atom. Do we get this? Want you to add another line to this definition, you can say that an atom is basically the smallest part of an element. And by that we mean it can be anything. It can be a metal, it can be a non-metal, it can be solid, it can be liquid, it can be gas. Does not matter. Now, the definition of atom can show up as either a 1 to 2 mark question. In your past papers, the definition of atom has not really like shown up for more than 2 marks, so make sure to prepare 2 points. You can either write like this part, that it is like all substances are made up of tiny particles. That would be considered 1 point, one bullet. And the other can be that an atom cannot be further divided. Or you could say that it is the smallest part of an element. Whatever works for you, just make sure that if a 1 mark question shows up, you're giving the examiner 1 point. If a 2 mark question shows up, make sure that you're either giving the examiner two separate, like two new points, or you're giving the examiner 1 point, and then for the second mark, you're explaining the same point that you just gave above. So make sure that you tick all the boxes for the examiner to give you like the 2 out of 2 or the 1 out of 1, because we want to bag all the marks out there. We don't want to miss out on anything. Okay, so I hope the part on atoms is clear. If any doubts, just comment down below and I'll try to reply to all of you guys. Okay, so we came across a term, sort of a new term, element. Oops, handwriting is a bit pathetic. Let me just, well, of an element. Ignore the mess, please. Now, what exactly is an element? An element is made up of atoms. Exactly what we said here, an atom is the smallest part of an element. So we can also say that an element is made up of atoms. Now, your elements are represented, they're sort of like, put together in something called a periodic table. Your elements are arranged in something called a periodic table. This is the arrangement of all of your elements. And this is the periodic table endorsed by AQA, your exam board. And this is exactly what you're supposed to access whenever you are doing chemistry. Okay, just make sure to type like AQA dataset and you're going to get like a bunch of formulas, and this periodic table. Make sure to always use this one because we want to familiarize ourselves with this pattern so we get used to this format, and when it shows up on the exam day, we're not like, all shocked that, oh my god, what is this? We should be aware. So I'm going to help you read this. Don't worry, I know it's like a lot at once, but just know that this is something that is known as the periodic table. And this periodic table basically stores everything about your elements. Period. I should be writing with a lighter color. Okay, this is your periodic table, and your periodic table has everything related to the elements. All of these individual alphabets, this HE, this is one element. All of these things in individual boxes, these are elements. HE, this is helium. Then we've got like below HE, we have Ne, that is neon. Then we have fluorine towards the left of neon. Then we have oxygen. Now these are individual elements. Nitrogen, N. Carbon, C. Boron, capital B. Do you notice that all of these elements are denoted, they're represented by a capital letter? It always starts with a capital letter. Yes, sure. For example, for rubidium, we've got RB. R is capital. For titanium, we've got Ti. T is capital. For chromium, we've got Cr. C is capital. So there are two properties. There are sort of two rules that are followed by the periodic table when representing elements. And that is your element is either going to consist of one or two letters. What I mean by this is fluorine, one letter, capital F, bromine, two letters, capital B, and the R, right? Manganese, two alphabets, capital M and a small r. And the second rule followed by the periodic table is that it is always going to start with a capital letter. Starts with a capital letter. And it is followed by a small letter. I'm pretty sure you cannot see any element in the periodic table which is like made up of two capitals. Like you would not see a capital Z or a capital R anywhere. You would not see a capital S and a capital U anywhere. It would always be S small u, Z small r. Because this is the format, this is the rule that we follow. It is followed by with any letter in lowercase. This is supposed to be case. Perfect. Now, you also need to know that all of these alphabets, all of these names, they are unique. O is for oxygen. Do you see O for any other element? Sure, for osmium, we've got O and a small s. But no other element is represented with just a capital O. So all of these names are unique to them. And no, you don't need to memorize this. This periodic table is going to be given to you in the exam paper. It is going to be given to you, don't worry. And these random numbers, again, I got you. No need to worry about this. Let's just focus on the alphabets for a bit. Now, it is unique and it has over 100 different elements. All of these are different elements, and I'm pretty sure some of them you've heard about. Fluorine in our toothpaste, magnesium. Do we not hear magnesium supplements? Take your magnesium. Then we've got oxygen. We breathe oxygen in. Carbon emissions. Aluminum foil. We use it to keep our food warm. Phosphorus. Phosphorus is in fireworks. Fireworks are made up of phosphorus. Right? Helium balloons, the helium challenge that went viral on TikTok, where you were supposed to like breathe helium in and it used to change your voice. So, most of these elements, some of them, we are familiar with them. They're all around us. Calcium, look at this, Ca calcium. Calcium is in milk. My grandmother made me drink milk all the time. Potassium. Do we not like hear about potassium supplements? We do, right? All of this information, these examples that I just gave, they're not part of your syllabus. Okay? You're not supposed to memorize them yet. Yes, there are some elements whose benefits and like advantages, disadvantages, purposes, uses you need to know of, but I'm gonna let you know I will be giving you all the notes, all the required information that you need to ace your exams. So I got you. And trust me on this, guys. If you do what I make you do, you are easily going to score a 9. And these notes are also going to be available to you in like a link down below. I'll be attaching the link down below. Just access these notes from the link and you'll be good to go and ready to sit for your paper, your exam. Okay, so all the elements are unique. No name is repeating. There are about 100 different elements in your periodic table, and your elements are arranged. Your elements, they are arranged in groups and periods. let me explain this. What do we mean by groups and periods? This is periods. Do you notice these random numbers? 1, 2, 3, 4, 5, 6, 7, 0. These are the groups. These are the groups. Let me help you with this. This first group, how many elements, what elements are in group 1? Lithium, sodium, potassium, rubidium, cesium, francium. All of these are group 1 elements. We call them group 1 elements. Now, the reason we've got groups and periods is because we want to give a name, we want to give our arrangement some sort of name, so we came up with the terms groups and periods. Where's my highlighter? Yes. So, all of these are in group 1. All of these are in group 1. All of these are in group 2. All of these are in group 4. All of these are in group 6. All of these are in group 0. After 7, nope, you don't get group 8. You're going to get group 0. And I'm going to explain why and how. So, these are your groups. Let me write this down. These are your groups, and you need to know that your groups are basically vertical. They run vertically down. Well, these are your groups, and they run vertically down. Now, please know that this element hydrogen, it is always going to be arranged in the same way. It is going to be like hanging in the middle, not really connected to any group. Please know the hydrogen is just consider it not to be in any group. It's just an element lying there. Call it useless. Okay? It's not really useless, but like just ignore it when it comes to groups and periods. Okay? Now, please do not access and start using random periodic tables on the internet, because some of them are going to have 27 written at the top and this 59 is going to be at the bottom for cobalt. Nickel is going to have 28 up and 59 down. Some of them might be mentioned in group 0 as group 8. We don't want to confuse ourselves because we are still in the beginning stages of learning and we've just started off with chemistry. This is the foundational topic. We don't want to confuse and burden ourselves with new information from different sources without having a strong grip of concepts. Okay, so now that we are done with groups, groups run vertically down. We need to understand what periods are. We don't really see any other number on our sheet. So, what exactly are periods? Periods are what run horizontally. Now, in period 1, no, hydrogen is not in period 1. Please ignore hydrogen when it comes to groups and periods. This is a period. Let me just write it like this. Might help you. These are your periods. They run vertically down. So this is period 1. It only has hydrogen. Period 2 has all of this. Period 3, whoa, period 3. Where's my eraser? Okay. Yeah. Awesome. So this is my third period, which has argon, chlorine, sulfur, phosphorus, silicon, aluminum. This is my fourth period, fifth period, sixth period, and seventh period. So, students, if anyone was to ask you, how many groups are there in the periodic table? What would your answer be? How many groups are there in the periodic table? What would your answer be? There are a total of 8 groups in the periodic table. We've got group 1, group 2, group 3, group 4, 5, 6, 7, and group 0, which is the 8th group. So we've got a total of 8 groups and 7 periods in the periodic table. Let's write this down. A periodic table has total of 8 groups in the periodic table plus 7 periods. Now, I've not really seen a question on define groups or define what a period is, but in case, just for to clear like our concept, you should know that groups, they run vertically down on the periodic table, and a period, it runs horizontally. These are basically the rows in your periodic table. Run horizontally in the periodic table, like horizontally sideways, however you want to put this. Now, this was us understanding the basics, the structure of the periodic table. I'm going to put up another periodic table because there's still more to learn and I don't want to overcrowd the one image that we have. Okay, so second periodic, the same thing. You can see that it's the same thing, right? You're always going to be getting this exact same format on your paper, nothing different. Okay, again, the rules stay the same. Obviously, 8 groups, group 7, and then group 0, the 8th group, the elements, they're unique. And they're unique. The first alphabet is always capital, the second one is always small, and this one box is enclosing one element. So, this beryllium, this is an element. This is one element. This hydrogen enclosed within a box. This is another element. Okay, now the new part, the thing that we've not really like discussed yet. We did talk about this being in group 1, column. This column with beryllium, magnesium, calcium being in the second group, and this one being in the third group. But what about this section? What's up with this section? This is not part of any group. Sure, it is part of certain periods. We've got period, let's look at this one where the periods are labeled. Yeah. So, we've got like this section runs from period 4, period 5, period 6 to period 7. So, definitely it has periods, but what about groups? This is not part of any group. This is because this section of the periodic table is. Wait, why am I coloring like a 2-year old? So, this part of the periodic table that is not really part of any groups, it's lined in the middle. This is known as R. Very important to know. This section is known as R. Any guesses? Transition metals. I'm just going to write on top of them. These are our transition metals. Please remember this. Now, transition metals. Transition metals have some metal, some metallic, and some non metallic properties. As you can probably tell from the name, transition metals, they're transitioning either into a metal or from a metal to a non metal. So they have like mixed properties, they can have dual properties. Now, how do we distinguish a metal from a non metal? I'm pretty sure that we know that carbon is a non metal. Yes, I'm pretty sure that we also know that oxygen is also a non metal. But how do we know if germanium is a non metal? How do I know if barium is a non metal? How do I know if potassium is a non metal? Thanks to this trick. Whenever you open your periodic table, guys, the very first thing that I want you to do is take a pen, a pencil. Please take a pencil. Do not put a pen on the periodic table because there's a chance that you might, run over something and the five would get missed or something like that. Just make sure to use a pencil. That's what I recommend. You're going to take a pencil and you're going to start drawing stairs from like this point onwards. So I'm going to try and draw a nice little stair. I obviously am not supposed to be. I'm not trying to be very careful with my lines. I know I'm hiding some numbers, but this is what my stair is going to look like. Pretty easy to draw if you know where to start from. So draw your stairs, and guys, this stair is your key. It is the key to making things simpler for you. Everything that is towards the left of these stairs, everything that is towards the left is a metal. Ignore the transition metals. We're not talking about the transition metals. We're just talking about everything that's outside of the transition metal. So I'm sort of talking about these two groups, and I'm talking about these areas, these parts. These are your not these all of them. All of these are basically your metals. Okay, and everything that is towards the right of these stairs, they are your non-metals. So silicon is a non-metal. Selenium is a non-metal. Why? Because it is towards the right of these stairs and we've made our lives easier. Yep. Hope it made sense. And let me give you another to make this even simpler. Here we go. Is this not what we just learned? Look at this. Let me adjust the image and it is going to be much easier. Look, the red keys denote metals, and they are again towards the right of the same ladder that we were drawing. Yes, they're towards the right. They are metals. And everything that is in yellow is a non metal. So always make sure to draw the stairs, and they're going to make your life easier. Much easier. So these were the basics, the fundamentals of the periodic table. Just a quick revision of everything. An atom is undivisible, it cannot be further divided. It is the tiniest particle that makes up any substance, any object, any solid, any liquid, any gas. And the definition of atom is important because it makes up your because it has shown up multiple times in the past. It is a very repeated question in your past papers. What is an element? An element is a substance that is made up of atoms, and all of the elements are assembled in something called the periodic table. The periodic table follows two rules. All of the elements are denoted by either one or two letters. The first letter is always capital and the second letter is always going to be in the lower case. All of these elements, all of these keys, all of these names, alphabets, they're unique. Not alphabets, but like the names are unique. There are about more than 100 different elements in this arrangement. They're groups that run vertically down in the column format. They're known as your groups. There are about 8 groups in the periodic table. Periods are the rows that run horizontally, and there are about 7 periods that make up your periodic table. Please, again, request ignore hydrogen when it comes to listing and talking about the periods and the groups. No, the examiner is not going to ask you which group is hydrogen in. No, the examiner is not going to ask you what period hydrogen is in. Ignore that. The elements that are in the middle of the structure, basically the structure, the elements that do not fall in any group, the elements in the middle of group 2 and group 3 are known as your transition metals. Always draw a ladder whenever you open up a periodic table because it helps you distinguish and easily spot metals and non-metals, because all of the elements towards the right are your metals and all of the elements towards the left of your stair on the periodic table, they are your non-metals. So I hope this part is clear, and we'll be moving on to chemical formulas next. There are some elements that you need to remember by heart. There are more important ones, and I'm going to let you know which ones to remember, which part to remember. Ignore these numbers for this lesson because we're going to dive into them in a bit. Don't worry, hold tight. We'll be doing and covering everything. Please make sure again to always open up and access the AQA endorsed periodic table. Don't just randomly go up on the internet and start searching random periodic tables because that is going to mess up your concepts. Stick to the AQA one, and you can access it on the internet. Just write AQA dataset, and a bunch of formula sheets along with the periodic table are going to show up. I would recommend and suggest always have a printout of the periodic table whenever you're doing chemistry, because this periodic table is very important. You almost need this table for almost every other question, even the practice questions that we would be doing. So, this is it for today's class, and I'm going to see you in the next one. We'll be diving into the more complexities, what these numbers are doing on the periodic table, and the chemical formulas, and how to make your own chemical formula if you come across a chemical. We'll be doing all of that. We'll be practicing some equations, what equations look like. We'll be doing all of that. So stay tuned because a lot is yet to come. Make sure to write your definitions and know your foundational concepts well because they are really important. You'll find the link to these notes in the link down below in the description down below, and make sure to leave a comment and subscribe to the channel and like the video if it was of any use, and I'll see you in the next one. Thank you. Bye bye.